that appear in the principle of conservation of energy. Hopefully you know that energy cannot be created or destroyed. It can only be transferred from one form to another. And the equation to calculate efficiency, you need to know the useful energy out divided by the total energy in. Okay, and just a quick one here. There's a little poll I'm going to ask you to do. Which of these is true for energy? Now, it might be more than one. So it's a multiple choice. You can choose as many of these as you think are true. I'm launching that poll now so you can see and vote for the ones. Choose as many as you think are correct.
Just a quick note, lovelies, if you can't see the poll, somewhere on your screen there should be 3 little dots. If you can find that and click on it, it should enable you to see the poll.
Okay, good. Lots of answers coming in. Going to give you just a little bit longer to make your choices. Okay, and all right, so I'm going to stop the poll and share the results with you. So nearly all of you spotted that energy can be transferred. Well done. Energy can be wasted as well. So well done, loads of you got that right. And dissipated, that's one that's slightly trickier. Dissipated means energy gets spread out to the surroundings. So think about you're bouncing a ball, the ball's bouncing up and down, and eventually the energy, the kinetic energy, is going to get turned into thermal energy when it hits the ground. And that slowly that thermal energy is going to spread out to the surroundings. That's dissipation of energy. So energy absolutely can be dissipated. Well done to those of you who got that. Okay, so today what we're going to be looking at is energy resources. And so there's these 3 points on your tick list. If you're following your tick list, we're going to be describing the main energy resources and compare how they are used and their reliability, identify the energy sources as renewable or non-renewable, and describing the environmental impact of using the energy sources. So what do we mean? Yes, first, Miss Wanstall, if you haven't already, can you start recording?
I have, sir. Did that earlier.
Good, thank you. Right, words are hard. So there's 3 areas in this topic where people struggle with the language they are using. The first one is looking at the difference between power, energy, and electricity. Now, in the everyday language, when you're talking to your family or your friends, you'll just talk about, oh, my phone's out of power. Is it? Is it out of power? Or do you mean it's run out of charge, it's got no electricity left in it? Turn the power off on the TV, stop wasting energy, your parents might say to you. Turn off the lights so you're not wasting energy. Be really careful in this topic because energy means something very specific, and so does power and so does electricity. So we're going to be talking about sources of energy, where you can get energy from on a large scale, and ways of generating electricity. So we touched on this already. Energy can only be transferred, released, wasted, or dissipated. It can't be produced, it can't be made, it can't be created, it can't be generated, and it can't be destroyed. The most important one there for today is generated, because electricity can be generated, and we're going to look at that in a minute, but energy can't be generated. The final one, which is a slightly tricky one, and to make sure you've got the right way round, is when we're going to be talking about pollution later. And I want to tell you, if you're in an exam and you write pollution as an answer and leave it there, you will not get the mark. Pollution is never the answer by itself. You need to say what sort of pollution is created, and we'll talk about some of those later. Okay, so when we're talking about sources of energy, we're saying, right, we want to power something big. We're not just talking about a little light. We're talking about a whole factory or a giant train or something like that. There are 9 different sources we can get that energy from. Fossil fuels. Now, you've hopefully heard a lot about these. Any of you who've been doing anything to the Extinction Rebellion or the climate protests, we're going to be touching on that this webinar. Coal, gas, and oil, these have lots of energy stored in them in chemical energy. Nuclear fuel, like uranium or plutonium, that has a lot of energy stored in it in the form of nuclear energy. Biofuel. Biofuel are plants that you burn. So for example, if you grow a tree and cut down the wood and burn it, that would be biofuel. That's a relatively slow growing one, but a better example is maybe you're going to grow a product like sugarcane or wheat, and then you're going to use that to get the sugars out of it and turn that into ethanol through fermentation, and that could be a biofuel. You can then burn the ethanol, but it came originally from plants. Bio, living, fuel, something you burn, it's something living that you burn. Wind, you're very familiar with. We've got the offshore wind farm. We'll be talking more about wind energy shortly. Geothermal, earth, thermal heat. The center of the earth is hot. There's a lot of energy stored there, which we can use to do useful things. The sun is a great source of energy. Again, we'll be touching on different ways we can use that. The waves in the ocean and the tides of the ocean are both ways of generating energy. Generating electricity, not generating energy. You can't generate energy. And finally, hydroelectricity, which we'll dig into a bit more in a minute. So these are the 9 ways, and this is something example says you need to know what these 9 ways are and know a bit more about them. What is it we're going to be using them for, though? Once we've got these energies, what do we use them for? We can use them for transport, for cars, trains, planes, boats, generating electricity, which then goes to houses or businesses, and for heating, maybe our homes, maybe heating other things as well. But this is why we need these 9 sources. And to do any of these 3 things, we're going to need a source of energy from one of those sources. So that's saying then you might be able to think of a 10th source in the form of hydrogen. Some of you might know about hydrogen fuel cells or hydrogen fusion. We don't have that. That's not one that we're going to be talking about today, but that will be touched on both of those things, hydrogen fuel cells and hydrogen fusion, later in the GCSE course. So there are others, but these are the 9 main ones which we're using currently to generate our electricity, or to use as an energy source for transport or heating. So all of these kind of fuel ones, biofuel, fossil fuels, nuclear fuel, and to an extent solar and geothermal, work in the same way. We've got a fuel that heats up water in a boiler and turns it into steam, and that steam drives a big fan called a turbine, creating kinetic energy, transferring into kinetic energy, which is then used to generate electricity in a generator. So all of these work in the same principle. We're going to heat water, turn it into movement, and then turn that movement into electricity. Great. One particularly cool one, this picture down here, hopefully you can see it all. This is a solar thermal tower. And the idea is here we've got hundreds of mirrors which are reflecting the sun, and they can rotate an angle. So they are always reflecting the sun up to the top of this tower. This tower looks like it's giving out a beam of light. It's not. The sun's going in, and all of that energy which is coming from the sun and landing on Earth is being focused onto this one point, which is then used to heat water up, turn it into steam, and generate electricity. So these all of these for generating electricity work in broadly the same way. We're heating up water, making kinetic energy, transferring to kinetic energy, which is then generating electricity. Some of these other ones, the water and wind one, moving water or air. We've got turbines here, but it's a much simpler process of transferring that kinetic energy into electricity. So wind turbines, the wind blows the fans around, and then inside here, that big turbine generates that from kinetic energy into electricity. A hydro plant, you have a big reservoir of water, you open a sluice gate, the water flows down and spins a turbine, which generates electricity. Waves under the water, the waves make those turbines rotate forward and backwards, one way and the other way, generating electricity. And the tides, when the tides come in, you can trap it on one side of a barrier and then let it out through driving a turbine, and when it comes out, it will trap on the other side and go through driving a turbine. Again, all of these turning kinetic energy into electricity. Our first point of extension, if you wanted to dig further into this beyond what your teacher sets you, understanding exactly how kinetic energy can be transferred into electricity. That's covered in a video here, and that is actually something which, if you're doing triple science, you will go on and look at in P2. But if you want to get a bit ahead of the game, there's some information there. There's one which doesn't involve kinetic energy, and that is solar cells. So we saw previously solar thermal towers, focusing all that sun's energy up to a point. These ones are kind of what you think of as solar panels, but in science we'd call them solar cells. And they do a weird thing where they take the sun's energy and turn it straight into electricity. They transfer it straight to electricity. Exactly how that happens is quite complicated. It's in A-level physics, and it's part of quantum mechanics. This is one of the first things that created the whole field of quantum mechanics. But I found a really good video which should be accessible to those of you who want to get an idea of the kind of cool things you might be looking at in A-level physics. So there's a link here. You'll have access to these slides after the webinar, so you'll be able to access that and watch that video if you want. That's probably not going to be part of the work your teacher sets you, but it's something which you might want to go on and look at just because you're interested. So we've looked at those 9 different energy sources and how we can use them to generate electricity, but at least one of them does not use kinetic energy as part of that. So I'm going to launch a poll asking you which one that is. Which one of those 5 that I've picked there does not have kinetic energy as part of its way of generating electricity?
Hello, sir.
Hello.
If possible, would you be able to move the little box at the bottom right that says you're sharing your screen?
Ah, okay, you can see. I've got rid of that now. Sorry.
Thank you. Also, if you've got any questions for Sir or for me, I am sitting here waiting to answer them. Smiley face.
I will go back and show you that picture of the solar thermal tower. You couldn't see them in a minute. Okay, but lots of you are voting on this poll, and I can see, yeah, good. We're nearly up to everybody having voted. Well done. And I can show you, okay, that most of you got it right. It is the solar cells. Those are the ones which just take the sun's energy and turn it straight into electricity. Nuclear, geothermal and solar thermal towers all involve heating up water so it turns into steam, and that steam, then the kinetic energy of that steam moving, that's what drives a turbine, and again that turbine's kinetic energy is then transferred into electricity. So well done. I'll just go back and show you the solar thermal tower because it's really cool. This picture, all these mirrors down here which are reflecting all of that light up to there. This one I think is in Spain where they get a lot of sunlight, so it's becoming, for those hot countries, it's becoming a very effective way for them to generate electricity. Okay.
It's a question for you.
Yep.
Are solar cells and solar panels the same thing?
Technically, no. Okay, so this is a distinction which used to be in GCSE and isn't there now. A solar panel is something you might see on a house which is used to heat up water. So they put the water for the house up to the roof, and the heat from the sun heats up the water, and then the house uses that hot water for showers and baths and washing up and all that sorts of stuff. A solar cell turns light from the sun into electricity. So solar panels and solar cells are different things. If you refer to them as solar panels though, you'll probably still get the credit, but technically they are solar cells. Okay, so we've got these 9 different ways of generating electricity, and one of the key distinctions between them is, are they renewable? When we say renewable, what we mean is a resource that is being or can be replenished as it's being used. So we've got those 9 up there, the 9 energy sources we've got. Which of those do you think, again, this is a multiple choice poll I'm about to launch, which of those do you think are renewable? So you've got 9 options. Tick as many as you think are renewable, and clearly don't tick the ones that aren't renewable.
Just going to restate in case you've missed it. This is the higher webinar. If you think you're in the wrong place, please check your emails. Mr. Lamb sent both web links out for you.
Okay, right. So I'm going to stop the poll there after about a minute and show you the results. So all of you said that solar energy is renewable. You are absolutely right. And loads of you said that wind is. Once again, it's a renewable resource. Another way of thinking about renewables is, are we ever going to run out? Now, that's not quite the right framing, but it's a way of getting you to think about it. Are we ever going to run out of this? So are we ever going to run out of the sun? Well, technically the answer is yes, because it's going to explode in about 4.5 billion years, but that's 4.5 billion years away. That's sufficiently far away that we can go, do you know what? That's fine. And if the sun's exploded, we've got bigger problems than not being able to generate electricity from it. So for all intents and purposes, we're never going to run out of sun. Are we ever going to run out of wind? No. Are we ever going to run out of waves? No, they're going to keep coming. Are we ever going to run out of tides? No, there's always going to be tides because the gravitational pull of the moon is going to be pulling the water around the Earth. Some of the others then, which some of you thought were, you were right. Geothermal. Is the Earth ever going to cool down to the point where it's not going to be hot enough to heat up water? Well, once again, sure, eventually in the super, super long billions of years term, yes, but for all intents and purposes for us, no. That is a renewable resource. It is never going to run out. Hydroelectric, that's the idea of rivers being dammed up and then going through a dam and turning a turbine. Are we ever going to run out of rain that's falling down and making rivers flow? No, we're not. Hydroelectric, once again, is renewable. Biomass is one that a lot of you thought was not. So remember, biomass is about living things, about things like trees or crops like wheat or sugarcane, which you can grow quickly and then regrow. Can we replace them? Remember, renewable is one that can be renewed. Can we grow more trees? Can we grow more crops? Yes, we can. Biomass is a renewable source. We can get more of them, so we can get more of that source of energy. And the other one, some of you said that nuclear is a funny one. Nuclear, we need to use uranium or plutonium. That's the fuel we need. And the Earth has a limited amount of uranium or plutonium. Once we've dug it all up, there's no more. So that is limited. Now, the Earth's got quite a large supply, enough for thousands of years, but once it's gone, it's gone. So technically, nuclear is not able to be renewed. We can't generate more uranium or plutonium on Earth. Maybe we could go out in space to get it, but that's a different problem. And all of you pretty much recognized fossil fuels are not renewable. It takes millions of years to generate fossil fuels, and we are using them up way faster than we are creating them. Okay, so here it is broken down for you. We've got 2 of them that are not renewable and 7 of them that are renewable. So renewability is an important thing which we need to think about when we're thinking about how we're generating our electricity. But another really important thing we need to think about is reliability. A reliable energy source you can be depended on to generate electricity, irrespective of what time of day it is or what time of year it is. It's constant. It doesn't rely on uncontrollable factors. So the same question, we've got those 9 energy sources. Which of those 9 energy sources do you think is reliable? So you've got the definition on the screen there. Can always be depended on, irrespective of time of day or year. It's constant. It doesn't rely on uncontrollable factors. So of those 9, which ones are reliable? Have a think, give it a go. Remember, you can tick more than one. Which ones do you think you can depend on? Okay, lots of votes coming in. Good job. Fantastic. A range of answers. So this one is, I think some of you aren't quite as clear in your head as renewable, but that's okay. We're going to go through it shortly. Just give you a little bit longer for some of you maybe to get your votes in. Okay, let's end it there after about a minute. And I'm going to share these results with you. Another way of framing this, so for renewables, I talked about, okay, are we going to run out? Another way of framing this is imagine ignore environmental things and cost to imagine, but imagine that you're in charge of the country and you have to pick one type of way of generating electricity, which is going to be, remember, we're ignoring environmental concerns for a minute, just we want to make sure that people have the electricity when they need it. Now, let's imagine you picked tidal, now, which has come out as the top answer in the poll. The way the tides work, in between the tides, there's a lot of water moving. So you can get a lot of kinetic energy, you can generate a lot of electricity. But at high tide and low tide, the water's not moving much at all. The majority of the water moves in the middle, in between high and low tide. So what that means is, if everybody wakes up and wants to put on the toaster and the kettle, but it's high tide and there's not a lot of water flowing because of the tide, you're not generating much electricity. So those people, and their toaster's not going to work and their kettle's not going to work. It's not reliable. You can't say, oh, we need some more. Can I just turn it up a bit? Can I get some more tide, please? And the answer is, well, no, you can't get any more tide. You can't control that. The same for wind. Imagine it's just not a very windy day. That happens sometimes. There's not a lot of wind, so the turbines aren't turning, so it's not generating electricity. It's not a reliable way to generate electricity. Waves, again, I went down to the sea the other day and it was still as a mill pond. Not very many waves, so I wouldn't be generating very much electricity. Solar is another unreliable one. For a start, it's dark about half the time. So if you want to use electricity at night, solar's not going to be generating any. The ones that are reliable are fossil fuels. Okay, they've got all sorts of problems with them, but you can turn them up. You can make sure that you've got the fuel there. You just have to burn it to heat the water, to generate the electricity. You can always do it. Nuclear, again, there's problems associated with it, but it's reliable. Geothermal, that you can always get access to the heat of the earth. Hydroelectric, you've got a big dam of water and you can let down as much of it as you need. And biomass, the same idea, you've got that fuel, so you're now able to burn it whenever you need in order to generate steam, in order to get the kinetic energy, in order to generate the electricity. I'm going to rerun that poll again at the end, because that's one you didn't get as right. So just remember, have a look at that one. We're going to do the reliable poll again at the end. So just have a little look at those. I'll give you a few seconds just to go through them.
Do you move the poll so they can see the non-reliable side?
Sorry, is that better?
Yep. Thank you, sir.
Okay. So have a look at those. I'm going to run that poll again. The correct answers are fossil fuels are reliable, nuclear is reliable, geothermal, hydroelectric, biomass. Okay. Right. Let's look at some of the downsides now. So this is moving on to looking at the environmental impacts. So one that a lot of you know a lot about already is fossil fuels. If you burn fossil fuels, it gives off carbon dioxide. We know that carbon dioxide creates the greenhouse effect, which causes global warming. Hopefully you're all familiar with that. If not, that is going to come up in the chemistry, if you haven't already, in chemistry paper 2. So we're going to be studying that in more detail again, but that is something which we covered in year 8 as well. So burning fossil fuels releases carbon dioxide. Those carbon atoms, which are now in the carbon dioxide, used to be locked away underground for millions of years, and we're now adding sort of new carbon dioxide. It's not quite new because it's been part of the earth, but it's been locked away underground. So when we burn those fossil fuels, we're taking those carbon atoms that were underground and putting them into the atmosphere. So that's why we're calling it new. Now, when you burn wood or ethanol that's come from plants, there's still carbon atoms in it. There's still carbohydrates, and they're going to be giving off carbon dioxide when they burn. So it looks like biomass has got the same problem as fossil fuels, because when you burn it, it gives off carbon dioxide. But that's not quite the whole picture. So over here, I've got my biomass burning. So here's my wood that's burning. And yes, it's giving off carbon dioxide. But remember, they came from plants, and those plants grew, and as they grew, they did photosynthesis, and they took in carbon dioxide. So then those carbon atoms that go to the furnace used to be in the air. Imagine if you took a snapshot, a picture of all the carbon dioxide atoms before the plants grew, and then you took another picture where everything else was kept exactly the same, but you'd grown the plants and then burnt the plants, and that carbon dioxide has gone back into the atmosphere. Burning those biofuels is not adding new carbon to the atmosphere. So they're described as carbon neutral. It's not unlike fossil fuels, which are taking them from the ground, the carbon that you're releasing when you burn biofuels was already in the atmosphere just a few years or sometimes months earlier. Okay, pollution. We mentioned before that just pollution by itself is never the answer. So when you're talking about pollution, you need to be specific about the kind of pollution. That often is a good answer. Just pollution by itself is never going to get you the marks. So just a few examples of types of pollution. Site pollution. And you're like, site pollution, that's the thing? Some people really don't like the look of wind turbines. They're a great example of something that causes site pollution for some people. I think they're quite nice. I'm very happy looking out at sea and seeing the wind farm out there. But there are people who think they're not nice looking. And those people would say, those wind turbines, they cause site pollution and also noise pollution. The blades spinning round can create a sort of a boom, boom, boom noise. And if imagine that's up on a hill near your house, then some people think that's not a great thing to have near them either. We've already talked about carbon dioxide, but just to remind you, that is a kind of pollution. And the other one is sulfur dioxide. Sulfur dioxide comes from fossil fuels with high sulfur content. Normally that means coal. Coal, as well as having lots of carbon in it, has lots of sulfur in it. When you burn that sulfur, it reacts with the oxygen to make sulfur dioxide. The sulfur dioxide dissolves in water in the clouds, in the raindrops, and falls as acid rain. So there has been a big problem historically with sulfur dioxide causing acid rain in certain parts of the world, notably in recent years in China, where they have a lot of coal-fired power stations. Nuclear power stations create radioactive waste. That is a byproduct of the nuclear reaction that happens, and that has to be stored and kept safe because it's dangerous stuff. It can cause cancer. It can even cause just straight up death if you have too high a dose of radiation. And although it might not be considered exactly pollution, I felt this fit best here, but effects on wildlife and habitats. So some people complain that wind turbines kill birds. Birds fly into them because the blades are moving around, and that destroys some endangered species sometimes. Or if you've got a hydroelectric dam, you need to build a dam and you need to flood a whole area behind it. So this used to be a river, but this river has now turned into a bit of a lake. So anything that was living on the banks of that river, their habitat's been destroyed. So these are some other environmental impacts that can happen from the different ways we have of generating electricity. Something else to think about is cost. Lots of these ways, in fact 6 of these ways, have no cost of fuel. The wind is free, the heat of the earth is free, the sun is free, the waves are free, the tides are free, and the water flowing down through this dam, that's also free. So that can be a really positive thing about renewable energy, is you're not paying for the cost of that fuel. You're not having to transport wood to burn, you're not having to pay someone to dig up coal, you're not having to pay someone to dig up uranium for your nuclear power stations. So a big positive when you're answering questions about these types of things can be the cost of the fuel. Another, clearly building any kind of power station, building anything costs money. Some of them are more expensive, and one of them that's clearly more expensive is nuclear power stations. Nuclear power stations, as well as costing a lot of money to build, once they're finished with their lifespan, they have to be decommissioned. And that decommissioning is basically taking them down so that they're becoming safe again. Remember, they've been full of this radioactive waste material. So all of those bits that have been contaminated need to be treated carefully and stored. And that is a very expensive thing. So that's kind of one of the big downsides of nuclear, apart from the radioactive waste and the potential for catastrophic nuclear accidents, like you might have heard of a few years ago in Fukushima, or you might have heard of Chernobyl. Again, there's been some instances of nuclear power stations exploding, either because they were badly built or they were built somewhere near tsunamis. Maybe top tip, don't build them badly, don't build them where you get tsunamis. Right, this is an environmental impact of biomass. So biomass, remember, we're growing plants to burn. Well, we've only got a limited amount of agricultural land in the world. And here's a graph from 2017, which is showing what it's used for. We've got a lot of it is used for pasture for animals, so for sheep and cows and pigs and things like that. A good chunk is used to just straight grow food for people to eat. And we've got a bit being used for bioplastics and a bit being used for biofuels. If we say, right, the solution to our energy needs is biofuels, we're having to say, well, which one of these are we going to sacrifice? Are we going to have less food for people in order to have clean electricity? Or should we be using that land to grow food to feed the billions of people who don't have enough food? So there's a bit of an ethical dilemma there with people who are promoting biofuels, because you're saying, I value my generating electricity more than I value feeding people who haven't got enough food. So just to be aware, biomass, some people think it's the answer, and to an extent, I think it has a place, but it does have this, okay, if we're growing things for fuel, I think there's a slight tension there. Okay, so we've been looking a lot at the how it's generated. You don't actually need to know lots about the detail, but you need to know enough detail about those 9 ways and how they turn it into electricity in order to understand the environmental impacts, the ideas of reliability, and the ideas of renewability. But you do also need to know about patterns and trends in electricity generation over time. So I've got 2 graphs here, and this is only a 5-year difference. You can see there's a huge change in 5 years. This one's from 2012, and this one's from 2017. And you can see what the pattern is coal is going away. Now, there's a couple of reasons for that. First, coal is a fossil fuel, so by burning coal, we're giving off carbon dioxide, which is adding to the greenhouse effect. Secondly, coal is one of those fuels that I said had a lot of sulfur in, so it's creating a lot of sulfur dioxide, so that's creating acid rain. So we have been shutting down or converting coal-fired power stations into gas-fired power stations. It's still a fossil fuel. We're still giving off carbon dioxide, but we're not also giving off sulfur dioxide. So that's been a pattern. And in fact, there was an article just today saying that as of Wednesday at midnight, the UK will have gone 2 months without burning any coal. And there is a link to that article down here if you want to read it. But it's brilliant that we are moving away from coal. It's a fossil fuel, and it's the worst fossil fuel. It's the dirtiest. It's got that sulfur dioxide, which causes acid rain. You can see gas, that has caused the amount of gas to increase from 27% to 41%. But overall, if you look at the total amount of fossil fuels, it used to be at 65% fossil fuel, and now we're down to 48%. So we are moving away from fossil fuels, and we're increasing the amount. You can see the amount of nuclear has gone up a tiny bit. There's been a big increase in the amount of wind and the amount of bioenergy from biofuels. And you can see that solar, which used to be in this 4% here, has been broken out to its own 3%. So we're getting more renewables. We're getting more variety of different ways of generating electricity, and we're getting fewer fossil fuels. Now, for a lot of people, they're saying that's not happening fast enough, but that is the trend that is happening. The final sort of bit in the specification that you need to know about is that the science has limits on what it's able to do. Science is able to identify environmental issues arising from the energy resources, but scientists don't always have the power to deal with it. So a really good example of this, it's not quite about environmental issues, but it's linking into the COVID crisis that's going on at the minute. This picture here shows Boris Johnson, the Prime Minister, flanked by the Chief Medical Officer and the Chief Scientific Officer. These are the 2 key advisors from the advisory group. And those are scientists who are working and advising the Prime Minister on what to do. But ultimately, it's up to the Prime Minister and the other members of the cabinet, the politicians, to choose which bits of advice they follow and make happen. So in the same way, scientists are saying to the government, hey, we've got big problems with generating too much carbon dioxide, and that's causing climate change. But ultimately, it's the politicians who are deciding what to do about it. And that is very frustrating for some of us in the science community. But again, that idea you need to be aware of. Scientists don't make decisions, politicians do. I did want to take a minute to just talk about this guy. Now, this is not something that you'll be assessed on, but I think this is something that's really important, and I really like being able to talk to you guys about this. Lots of you have seen in the news recently, Black Lives Matter. They absolutely do, but I'm of the opinion that black science matters as well. And this scientist is an American scientist, John Dabiri, and he originally started working, he's a marine biologist who started looking at jellyfish. And he was studying jellyfish. And like, well, why are you telling me about this? It does link to what we've been talking about. He was also studying schools of fish, so groups of fish and how they swim and the mechanics of how they kind of line up in order to take advantage of like slipstreams and little vortexes, little spirals of water from each other as they swim in a school. And that's what this diagram shows. Here are the lead fish, and this fish here is positioning itself so that its little vertices, its vortexes, line up with the vortexes of the other fishes to make it easier so it swims faster. He's taken that idea and he has put it into play for these vertical wind turbines. So instead of the big bladed ones that spin round and round and round, take up loads of space, these are vertical ones. You might have seen them driving around on the M25 around London. Sometimes you see a few of them. There's a central pole which things spin around that way instead of that way. And he applied this idea of looking at how the fish line themselves up in a school to over here. If you've got the wind coming in to these vertical wind farms, how should you space those to maximize the amount of electricity you're generating? So we don't often get a chance to show you some black and minority ethnic scientists in science, so I wanted to take this opportunity. He's fantastic. Again, if you're looking for some extension work, go and have a look at the work he's done on jellyfish. It's really cool. And the stuff he's done about generating electricity. Okay. I've just got a little bit of time left. I wanted to talk to you about some of the exam questions that your teachers might be setting you. So I've put together a whole load of exam questions on this topic, which are higher tier exam questions. So I just wanted to give you a little bit of advice on these. My first piece of advice is look for the key word in an exam question. So here it's give. So that's easy. You just write down one thing and it tells you give one advantage, give one disadvantage. The other thing to look for is the number of marks. Here there's 2 marks. So how do you get the 2 marks? Well, write an advantage there, write a disadvantage there, you get 2 marks. That's easy. Some of them are more complicated. Here's an explain question. If you see the word explain, that means you're probably going to use the word because somewhere in there. If you're not using the word because, you're not explaining, you're probably describing. And there are 3 marks here. So in order to get those 3 marks, you need to give 3 good reasons. This word suggest is another command word, and it means use the information in the question and what you know to say something sensible. There's probably more than one right answer, and so long as what you're saying is vaguely relevant, you're probably going to get the mark. So suggest can be tricky, but that's what that word suggest means. Here again, we've got an explain question. So we're looking for a because. Explain which energy resources in the graph should be used to meet UK's commitment to the Paris Climate Agreement. So you've got to tell me which they are and then tell me why. Again, another explain question. We're looking for a because answer. Another suggest question. Use the information plus what you know to say something sensible. That's what that means. Here we've got a describe. Now here, it's described, you're not necessarily needing because. Here you are describing the environmental advantages and disadvantages of using wind turbines to generate electricity in the UK. Now there are 4 marks, so you've got to think, how am I going to get those 4 marks? Well, I've got to give advantages and disadvantages. If I gave 1 of each, I'd probably get 1 mark for the advantage, 1 mark for the disadvantage. I'm only going to get 2 marks there. It's got 4 marks. Maybe I should give 3 advantages and 1 disadvantage, and that might get me 4, or 2 and 2, or 3 disadvantages and 1 advantage. My advice to you is try and over answer the question. Try and give me 3 advantages and 3 disadvantages. That way you're like, well, maybe I'll get 6 marks, but you should guarantee getting those 4, even if 2 of them maybe aren't quite right or don't quite apply. You've still hopefully got those 4 strong answers in there. So try and give in that question 3 advantages and 3 disadvantages. A nice simple one here, 1 mark question. What's meant by reliable? Just give me a definition. Maybe you need to look back at this video again to remind yourself of that. What does it mean to decommission a nuclear power station? Again, maybe you need to look back in this video. Give 2 ways, 2 marks. Again, it's really clear what you need to do to get those marks. But here, outline the arguments. And again, we've got 3 marks. So I'm looking, so outline is the command word. We've got 3 marks available. I'm looking for at least 3 things, but try and over answer the question. Can you give me 4? Can you give me 5 of the arguments? Suggest one reason why people are against burying nuclear waste. Again, it's got that suggest. That word suggest means you probably haven't been taught it, but maybe you can figure it out. That's what that word suggest means. Another suggest question. Suggest, again, 3 marks. Can you give me 3 points? Great. Can you give me 4 or 5 points to make sure you're getting those marks? Right. Now, this is another classic thing we do in science exams, is give you a table which you need to extract information from. So here is a table. Look at the table carefully. The command word is suggest, and there's 2 marks. When you see 2 marks, that can sometimes mean give 2 points, or it can mean give 1 point and explain it. So you've got to kind of use your judgment as to which you think is the right one to use there. If in doubt, give 2 points and explain both of them. Right, I really wanted to show you this because this is something they love doing in science. This is a high level question. This is a sort of a grade 7, 8, 9 kind of question, this question. What they've done is they've given you something here which you have never heard about, something called capacity factor. And they tell you how they work it out, and then they give you a table with it in. So nowhere in the specification does it tell you to teach you about capacity factor. This is something that they have thrown at you to see if you can deal with it. So if you're looking at that and going, I have no idea, that's the point. You need to read the information carefully and then try and figure it out. Again, we're looking for explain, that's the command word, and there's 3 marks, so we're looking ideally for 3 things that you can say about it. So just wanted to run through those quickly. And the very last thing I wanted to do was to go back and relaunch this poll. So that you can see, have you remembered which of these energy sources are reliable?
Hello. Just very quickly before we run out of time. So
Yep.
these exam questions are going to get uploaded onto Classrooms for you to have a go at. Your teachers will explain more, but they are high ability. So for some of you, don't stress too much, just give it your best shot. And if you've got any questions, we've got about 3 minutes. So if you have, just chuck them into the question and answer box now before we have to actually log off. Thank you.
Okay, it's looking like coming in with your votes. Lots of you have remembered which of those are reliable and which ones are not reliable. Those of you who are struggling with this a bit, go back and have a look at the explanation again in the video, or have a look on Bite Size, or hit up your teacher to remind them. But lots of you, I'm really pleased, 94% of you saying fossil fuels are reliable. Fantastic. Oh, 92. Right. Okay, guys, like I said, we've got a few minutes if you do have any questions. My final thing I wanted to say is a thing that your teacher may ask you to do. I think this topic lends itself really well to a mind map, breaking out, so power generation, nuclear energy, and you could come off here, advantages and disadvantages. Solar cells, I prefer, advantages, disadvantages, wind turbines, advantages, disadvantages. Just those 9 energy sources around here, and then each one broken off into advantages and disadvantages, just because that's the kind of question that comes up a lot. So knowing those, particularly the environmental ones, really, really should help you.
Okay, so I've got one question, which is what is geothermal? Geothermal
is using the heat of the earth to heat up water. So you dig down and you put pipes into the ground. As you go down, it gets hotter and hotter and hotter. The heat heats up the water in the pipes to make steam, which drives the turbine, which generates electricity. There are some places in the world, like New Zealand and Iceland, which have naturally occurring geothermal springs, hot water springs, and all you need to do is put a turbine on top of them, and you're getting basically free electricity with no carbon dioxide being created. It's really good. Not something that happens in the UK, so we would have to actually dig down and lay pipes in order to get that effect.
Okay, so I'm going to stop the recording because we're at 1